So once the bus door closes and prepare to leave the bus stops, okay, this period of time we name it, we call it clearance times. We assume that during this period of time there is no any bus can enter the bus loading areas of the bus stops. Okay, this is what we call clearance times. So there are two ways for us to estimate the time of clearance. One is by the default values. We put 10 seconds if we don't have the true values, or we collect the data from the sites, okay, from the fields. Okay, this table can be used to estimate the clearance times based on the traffic flow. Okay, on the first columns, okay, range from 100 to 1,000, and on the second column it gives the clearance time estimations. Okay, due time variability. Okay, so due time is not a constant values. Sometimes it can be lower than the average. Sometimes it will be greater than the average. So that's why there is a variation for the due time. So we use a coefficient of variations, okay, to measure the variability in due times. We call it CV. So CV, take this simple equation. CV is equal to standard deviation divided by average, and CV cannot take negative value, for the reason because of standard deviation cannot have negative values. So if CV is equal to 0, so means that all due time are the same. So means that the due time is constant, but this is very unlikely. So how about if CV is equal to 1? So it means that about 1 in 3 buses have a due time 2 times larger than the average. So in short, CV can take minimum value is 0, and there is no any maximum boundary value for CV. So CV equals 0 and CV equal to 1 is for you to imagine, okay, how are you going to interpret the other CV values. Okay, if we plot a set of due time in histogram, we will see a normal curve or the bell-shaped curve. The width of the curve will indicate the due time variabilities. If the curve is flat, it indicates that there is high due time variations. Conversely, if the curve is narrow or thin, then it means that the due time variability is low. Okay, what is maximum capacity of the bus stop? Bus is available to move in to a loading area as soon as the previous bus vacate it. So means that there is no waiting time. The moment the bus arrives, it can move into the loading area. So the loading area is always empty. So if this condition happens, so means that we'll achieve the maximum capacity of the bus loading areas. So capacity will be affected if there are 3 points: the travel speed reduced, bus travel speed reduced, time spent waiting for the loading area to become available. It means that, okay, it depends on how long the bus have to wait until it can move into the loading areas successfully. So because of we are talking about journey speed, we are not talking about the running speed. So that's why the time taken for the bus to wait, so means that it will reduce the bus travel speeds. Okay, the second point, the bus schedule reliability suffers. So because of the bus have to wait, that's why it will delay the schedules. So the schedule will become a very means that the bus cannot follow the schedule tightly. The third point is the bus block traffic in the street for a longer period of time. So because of the bus is queuing outside the bus stop, that it will occupy one lane of the routes. Then perhaps if the bus stop located at the heavy traffic flow routes, that means that it will block other traffics. Okay, the purpose of this slide is to explain the definitions and the computations of operating margins. So operating margin is computed based on using 3 terms, okay, as shown in the first bullet point: failure rate, okay, combined with due time variability and average due time. So first, what is failure rate? Failure rate is a probability term. Okay, it indicates how likely when a bus arrives at the bus stop but it failed to enter the bus loading area immediately. So this is what we call failure rate. and this rate is predetermined. We decide what is the expected failure rate, and due time variability and due time can be obtained from the field studies. So what is operating margins? So refer to the second bullet. So according to the definitions, it given is the maximum amount of time a bus due time can exceed the average without creating the likelihood of a bus stop failure when the number of buses scheduled to use the stop approaches its capacity. So means that specifically we refer to when the bus stop capacity is approaching the capacity. So operating margin is the maximum of time. So the due time still can greater than average, and it won't give any big implications on the capacities. So this is what we call the operating margin. Okay, the third bullet point indicate that when we say if the lower failure rate, it will increase the operating margins and schedule reliability. But at the same time, because of we want to make sure that the failure rate is low, then that's why we will suffer because of we will have lower loading area capacities. Okay, so now mathematically we can see that we refer to this normal curve. The orange area or brown area indicate the probability that any given bus due time longer than the Z values. So we look at this equation, the first equation in this slide. So Z is equal to TOM divided by S. So TOM is what we call the operating margin. S is the standard deviation of the due time. So TOM is in fact is the TI minus TD. TD is the average due time. So TI is the specific due time we are focusing on. So this is what we call Z is standing for the normal distributions. So now because of our aim is to find the TOM. So the equation on the top slide, so TOM is equal to S standard deviation of the due time multiplied with the Z values. Z is a normal as I mentioned just now, and S can be written as CV TD Z. TD is the average due time. So this is according to the definition in the last two slides for operating margin. So now we want to, if we want to find what is the TOM, the expected or the estimated TOM, first we have to know what is the variability of the due time S, and Z depends on the failure rates probability assumptions. So we can assume as low as 1%, as high as 50%. In fact, it can be range from 0% to 100%. So this table shows if we want to have 1%, so the Z value is 2.33. If we go for 10%, the value is lower, is 1.280. So means that when we want to have a lower failure rate, the value of Z is highest compared to when we want to have a higher failure rate, the Z value is lower. So this is how we find the TOM.